Hello guys, how are you doing? In the last video, we talked about some experiments conducted by Galileo and the fascinating conclusion he derived from them. Galileo said that if an object is at rest or if an object is undergoing uniform motion, then no net external force acts on the object. Yes, that's correct. No net external force acts on the object at all. On the other hand, if the object does experience a net external force, then its state of motion changes, which means a resting object begins moving, and if the object is already moving, then its speed of motion changes. Now, Isaac Newton was a successor of Galileo and also a bright kid of his era. So, he took this idea and formalized it into the first law of motion. So, Newton's first law of motion states that an object at rest would continue to be at rest. An object undergoing uniform motion would continue undergoing uniform motion until a net unbalanced force acts on the object. Now this is a simple statement, yet a profound one. So let's analyze it step by step. So Newton wants you to know that if a body is at rest and no unbalanced forces act on it, then the body can stay at rest forever. Similarly, if a body is moving at a uniform velocity and no net unbalanced forces act on it, then the body can continue moving at the same velocity forever. But if the body experiences an external unbalanced force, then it either accelerates or decelerates, which means its state of motion changes. Now at this point I must tell you that the terms external unbalanced force and net external force mean the same thing, and I'll be using them interchangeably throughout the video. So guys, now that you are clear about the basic message of Newton's first law, we can state it in a different way as well. So we can say that a body accelerates only and only if a net external force or an unbalanced force acts on the body. Otherwise, the body maintains its state of motion and stays unaccelerated. Now another important point I must tell you here is that when a body maintains its state of motion, we say that the body is in equilibrium. So body in equilibrium either is at rest or is moving at a uniform velocity. It's a minor technical term, but you should know it because we'll be using it in problem solving. Now Newton explains that the first law of motion holds true because all physical bodies in the universe possess something called inertia. Now in English language, the word inertia literally means idleness or laziness. So Newton is saying that all physical bodies in the universe are lazy by nature. Why? Well, you see, because physical bodies don't want to change their state of motion by themselves. Instead, we have to literally apply a force to do so. So, in the context of physics, we can understand inertia as a body's resistance to any change in its state of motion. Let's understand this better with an example. Imagine a scene where Jack decides to kick a football and a bowling ball with the same force. Now obviously, when Jack kicks the football gains a high speed and travels a large distance. But when Jack kicks the bowling ball, it gains only a low speed and barely travels any distance. And not to mention, hurts Jack's foot. Now why does this happen? Well, you see, one-line answer is that the inertia of the bowling ball is much higher than the inertia of the football. Due to its high inertia, the bowling ball heavily resists Jack's efforts to change its state of motion and therefore hurts his foot as well. But football, owing to its low inertia, doesn't resist that much and easily gains a high speed after the kick. But hey, let's hold on for a moment. Even if we did not know the concept of inertia, we definitely knew that Jack is going to hurt his foot the moment he strikes that heavy bowling ball. How? Well, because we intuitively understand that striking or kicking lighter objects is easier than striking a heavy object. So does this mean that mass of an object has to do something with its inertia? Yes. Bodies of high mass have high inertia, while bodies of low mass have low inertia. This means that it's easy to move lighter objects as compared to heavier objects. And that's why many times scientists consider mass as a measure of the inertia of an object. Well, that's fascinating, I'm sure. Great! So guys, that's it for today. I hope you had a good time learning about Newton's first law of motion and also the concept of inertia. In the next video, we'll talk about a physical quantity called momentum that will eventually help us understand Newton's second law. Till then, Let's summarize whatever we have learned so far in this video. Newton's first law states that a body at rest would continue to be at rest. A body in uniform motion would continue to be in uniform motion until an external unbalanced force acts on it. Newton's first law can also be stated in a different way. A body accelerates only and only if an external unbalanced force acts on it. Otherwise, the body maintains its state of motion and stays unaccelerated. Inertia refers to a body's resistance to any change in its state of motion. Higher the mass, higher is the inertia of the body.